Okay, now, with these, I want you to remember that if you've got displacement equals f of x, then velocity equals f dash dash x, and acceleration, actually instead of d, I'm going to do, instead of f, I'm going to do d, so the derivative of the displacement is the velocity, the derivative of the velocity is the acceleration. Normally we do displacement with s's, but you know, it honestly doesn't matter. So for 1a, well, we need x dash, which is okay. We're treating displacement as a function x of t. So this is like f of x. We're finding the first derivative for the velocity, first derivative of that for the acceleration, which is just the second derivative of the displacement. It honestly doesn't matter. You're going to derive it, sub stuff in. 3t squared take 9 at t equals 3. The velocity is 3 times 3 squared take 9 equals 18 meters per second. Okay, B. Find the acceleration after 2 seconds. So we're finding the double derivative. So we're deriving it a second time. So that becomes 6t. So 3t squared take 9. The derivative of that is just 6t. At t equals, they give us time 2. X dash dash equals 6 times 2 equals 12 meters per second squared. Question C. Show that the particle is initially at the origin. So when it says initially, that means at t equals 0, the particle equals 0 cubed take 9 times 0. So 0 meters away. So to find any other times, we just have to sub in 0 equals t cubed take 9t. If we have t squared take 9, that's the same as t take 3, t plus 3. So t equals 0, t equals 3, t equals negative 3. This is seconds, so we don't count this final answer. D, find after what time the acceleration will be 30 centimeters per second. Well, I was just automatically in meters. Centimeters, 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 whatever. So this time we know acceleration is 30, and that's 6t. We found that previously. So t equals 5 seconds. Not too hard. Question 2. Okay, so initial velocity, again, we just need the derivative of the displacement. So that's 4t take 8 at t. So whenever they say initial, I want you to assume t equals 0. So it's -8 meters. So it could be like below ground or something. B, the acceleration, so the second derivative, so we've got for take nothing, so it's the derivative of the velocity, yeah? So all we needed to find was the derivative of the velocity, which is 4 meters per second squared, and this should have been meters per second. Question C, find the displacement. So after 5 seconds, 2 times 5 squared, take 8 times 5 plus 3. So that's 13 meters. So it's at 13 meters after 5 seconds. Question D, when the particle will be at rest. So it's at rest when the velocity equals 0. So that's when 4t take 8 equals 0, so t equals 2 seconds. Question E, what would be the particle's displacement at that time when t equals 2, s equals 2 times 2 squared, take 8 times 2 plus 3, which is -5 meters. Again, it could be below ground. F, do I really want to sketch this? So we're sketching S equals 2t squared, take 8t plus 3. Y-intercept, x equals t equals 0, so y equals 3. I'm saying y instead of s. So x-intercepts, sorry, t-intercepts. So I've got 0 equals 2t squared, take 8t plus 3. So t equals minus -8 plus minus, yeah, I'm going straight into the quadratic formula. It's late and I'm tired. -8 squared, take 4 times 2 times 3, all over 2 times 2. Any nice numbers going to 40? 4 does. 2 root 10. So I've got the feeling one of these is going to be a negative. Obviously not 2 plus root 10 over 2, but I've got the feeling 2 take... No, they're both positive. Oh, look, I'm so over this. Don't bother sketching it. No, thanks. I mean, we could sketch it on Desmos. Question 3. And we're not going to sketch this one either, because I'm a rebel. Okay, there's that word initial again. So we're going to have t equals 0. So the height is 4 meters. The initial velocity well, to find the velocity, we need to find the first derivative of the height. So that's 40 take 10 t. T equals 0. The velocity is 40 meters per second. C. Height after 1 second. T equals 1. H equals 40 times 1. Take 5 times 1 squared plus 4. 39 meters. D. The maximum height. Now the maximum height is always at the vertex, also known as the turning point. Now, if we sketch any of these, the vertex is always when the derivative equals 0. If it's going up and turning back down, this point is when velocity equals 0. That's not actually in the Year 11 course, it's in the Year 12 one, but we'll do it. So we've got 40 take 10 t equals 0, t equals 4 seconds. So the height is 40 times 4, take 5 times 4 squared plus 4. $84 meters. And I'm not going to sketch it. Question 4. For 4a, again, initial, we're thinking t equals 0. So its initial displacement is 2 meters. B, it's at the origin. So we're assuming x equals 0, so 0 equals 2 take t squared. 0 equals minus t squared plus t take 2. Factorising it, yep, that comes out as that. So t equals -2 and t equals 1. Can't have negative time, so t equals 1 second. Okay, question C. Displacement after 2 seconds. So x equals 2 take 2 squared, so that's -4 meters. How far will it move in the first 2 seconds? Well, if it started at 2 meters and ended up at -4 meters, it moved from 2 meters to -4 meters, so 6 meters. And E, find its velocity after 3 seconds. X dash is going to be -1 take 2t. T equals 3. X dash equals -1 take 2 times 3. -7 meters per second. Question 7. Why did I set you all these questions? Okay, the equation for the velocity is the first derivative of the displacement, so that's 3t squared plus 12t take 2. The equation of the acceleration is the first derivative of the velocity, so it's 6t plus 12. Displacement after 5 seconds, t equals 5, x equals, so I've got 5 cubed plus 6 times 5, take 2 times 5 squared, take 2 times 5 plus 1. Velocity after 5 seconds, so I've got 3 times 5 squared plus 12 times 5, take 2, 133 meters per second. And the acceleration after 5 seconds, 6 times 5 plus 12, 42 meters per second. Wow, that's going really quickly. I mean, that was a nice quick question, but it's still annoying. Okay. For x dot, so for velocity, we've got 5 lots of 4t take 3 to the 4 times that 4 on the inside. So we've got 20, 4t take 3 to the 4. Second derivative for acceleration, we've got 80, 4t take 3 to the 3 times that 4, 320. Okay. X is going to be 4 times 1 take 3 to the 5, which is 1. X dot, 24 times 1 take 3 to the 4 is going to be 20. X dot dot, 320, 4 times 1 take 3 to the 3, 320. So this is meters per second squared. Describe the motion of the body after 1 second, very quick and speeding up. I don't know what they want. That'll do. That's question 8. Question 9. This is one of Newton's laws of motion. Physics students will recognise this one. Okay, the equation of the velocity. So we've got S equals ut plus half gt squared. The velocity is the first derivative of the speed. So we've got u plus 2 times half gt, which is just going to be u plus gt. U plus at for physics students. And they've told us u is 5. Yeah, numbers. Okay, for B, at t equals 10, v equals 5, take 10 times 10, v equals negative 95 meters per second. Show that the acceleration is equal to g, okay? The acceleration is v dash, which is g. What do they want? So that's u times 0 plus g times 1 t to the 1 take 1. I don't know. There's only so much that you can do to show that it comes out as g. That was that one. Okay, 10. Okay, so we got s equals 2t take 5 over 3t plus 1. We're going to have to use the quotient rule for v. So we've got 3t plus 1 times 2 minus 2t take 5 times 3 over 3t plus 1 squared. So that's going to give us 6t plus 2. I'm going to simplify this because I do have to I have to differentiate it again to find acceleration. Take 6t plus 15 over 3t plus 1 squared gives us 17 over 3t plus 1 squared. Okay, if I want the acceleration, I now have to derive this again. So we've got 3t plus 1 squared times 0 minus 17 times 2 lots of 3t plus 1 to the 1 times 3 all over 3t plus 1 to the 4 gives us negative 102 3t plus 1 over 3t plus 1 to the 4. So stuff's going to cancel. We've got negative 102 over 3t plus 1 to the 3. That's it. Next they want this one. I want this one. Okay, so initial velocity, well, we need to find x dash. So that's 3t squared take 8t plus 3. Initial, that means t equals 0. It's going to be 3 meters per second. Times when the particle will be at the origin, that's when x equals 0. So we've got 0 equals t cubed. Take 4t squared plus 3t. Now we can factorise the t out. And we can factorise that bracket. So that's going to be t take 3, t take 1. So t equals 0 seconds, t equals 3 seconds, t equals 1 second. And you could write them in order if you wanted. And acceleration after t equals 3, so that's x dash dash. So that's going to be 6t take 8. So it's going to be 10 meters per second squared. Okay, that's question 12. 14. Okay, 2 more to go, I hope. No, do it down here. Okay. Initial height, it's 7 meters because you're subbing in 0. Max height, is when the velocity is 0, when the derivative is 0. You could figure out the vertex minus b over 2a, but this will do. So that's 6 take 2t. So t equals 3 seconds. So h equals 7 plus 6 times 3 take 3 squared. (16 meters). It will reach the ground. So that's when the height is 0. So 0 equals 7 plus 6t take t squared, which is negative. T squared takes 6t plus 7. T takes 7t plus 1. Nope. That's because that should be -7. That's it. So we've got 7 seconds and -1 seconds, but obviously can't have negative time. I'm not going to sketch that. How far will it travel in the first 4 seconds? So the height equals 7 plus 6 times 4, take 4 squared, which is 15 meters. Started at 7 meters. So it travelled 8 meters. Okay. And one more. Once more with feeling. Once more into the breach. How far up the slope will the ball roll before it starts to roll back down? So it's going to go up and down, and it's going to start going down after the velocity equals 0. So x dash equals 0. That's 15 takes 6t. So t equals 15 on 6. 5 on 2, which is 2.5 seconds. Its velocity when it reaches 0, or when it reaches the base of the slope. Sorry, just some housekeeping. That's better. So it reaches the base of the slope when x equals 0. So 0 equals 15t take 3t squared. So t equals 0 and t equals 5. So when t equals 5, x dash equals 15 takes 6 times 5. Negative 15 meters per second. It's negative because it's rolling back downwards. How long will the motion of the ball take altogether? I don't know, 5 seconds. Yeah, because if it's starts at 0 seconds, goes up the slope, then comes back down, that's taking 5 seconds to get back down. I think that's it. Oh, good. I much prefer doing these questions in physics when you have easy